So welcome, big turn up. Are you mocking me? Is my talk today. I'd like you all to be welcome. The talk is about a solution I did at my current assignment. It's about GraphQL mocking test data, the solution that we use there. But I would like to start off with a question. Who of you used mocking in testing before? Just by show of hands. Oh wow, that's really like 50%. Do any of you know GraphQL? Also a few. Okay, good. So that's just to start off with a little bit about me. Skiing, biking, some environment pictures. I work for the testers. It's a company with just like 17 or 18 employees. We're all test automation engineers. And I've been with a few clients. And the current one is the Port of Rotterdam. And this talk is based on my experience there. The picture that is showing there is the view from my office. When I'm not working from home, I'm in Rotterdam Center. And this is the view I have. And this one is a ship from Rotterdam itself. And it's like it's like celebrating something there, like sprouting all the water. It's a real nice event there. But mocking. These are just a few terms. I think the main one is test double. That's just the generic term. And I don't like to talk about all the terms or whether or not you should, because I think you should use mocking when it's fitting for your assignment. I use it with great pleasure because it helps us testing. We don't have to be reliant on a lot of services. We can just use everything that we need at our disposal. And for once, I thought a great example is like when I practiced this presentation, I couldn't get 500 people in my living room, so I had to settle for this. Their feedback was a little low, I guess. No questions asked afterwards. But well, I had to try and practice this one. It was really nice. So let's go on to our brief. This is the situation we're talking about. We're creating a front-end application. It's built in React. It's using GraphQL, and it's Apollo GraphQL to be exact. And GraphQL is like the middle layer. It will talk to our backend services. So from a UI perspective, you don't need to talk to like 50 or 60 or how many microservices you have. You don't have to know about all the endpoints that are there. You only have your GraphQL. And GraphQL is just one single endpoint, and you can query it, and you get your data. So from a UI perspective, it's very easy. And from a testing perspective also, but I will get to that later. Just to get some insight, this is all the microservices that are present in one environment. It's like the test environment. Every group is a pod. So I've counted it. I think it's about 60 at the moment, and it's still growing. Microservice environment. They will just make more and more. Every feature, every function has to be its own pod. Maybe it shouldn't, but we have. And this is the application we're talking about. This is just a small view where we are looking at a visit from a ship to the Port of Rotterdam. And we like to show some information. This is test data. It's mocked data. But to come to this page and to show this information, we already need 25 unique calls to the backend, or 25 queries to our GraphQL server. And next to these 25 queries, we also have like 8 to 10 subscription-based events, so where the server will push information to the front end when there is a change. So that's a big amount. And if you think about a test perspective, and you need to be able to provide your application with data, and looking at all these calls, some of these data points require like JSON objects, JSON files for over 300 lines. And if you have to create that for 25 endpoints, that's a lot of work. And we don't want to use the real endpoints, because then we're limited by the data that is there. And we don't want to create our data by sending requests to outside services, because some services are outside the realm of Port of Rotterdam. So, just to give you some idea of why we are mocking, this is our data setup in our test case. It's just these 6 lines of code. As you can see, we have some store, and we are adding a visit. And the only key information we need is the name of the ship. So that's the Maersk Gironde. And you can see it also on the view in the back. And every visit has some movements. So we add a movement. And for this case, this specific case, we needed something with a pilot. And it shouldn't be a special transport. But that is all. The only thing we had to do in our test case is just add this data, and our mock GraphQL server would take care of the rest. So how does it work? You can see the pictures above. It's the UI, it's the GraphQL, and it's our backend services. So we have our test tool, and our test tool is working against our application. That's the page under test. But instead of talking to a real GraphQL server, the application will send its request to our mock server. And this mock server doesn't talk to backend services anymore. It will talk to a state-managed test data container using Redux and SQLite. So a small disclaimer. In this setup, I used TestCafe for a front-end testing tool. We use Apollo GraphQL, and we use the Redux and SQLite. You can use another tool stack if you wish. The tool stack itself is not really important. I guess Apollo GraphQL is, because that server is what is making the mocking possible. But what tool you use for testing your UI application, it doesn't really matter. As long as you have the possibility to intercept REST requests that are sent to the GraphQL server. So looking at a test flow, the perspective from our test tool, you can see above we have a few steps, like a fixture. A fixture is a group of tests. Within that, there's a test. We have got our page, we got our store and our database. So every time we start a test, it will create a database with just static information. It's like data that can be used by any test case. It's not bound to any test case, but it will contain some information about birds or ships. After that, we initialize a store, because every fixture, every group of tests has its own test data state. And that state is kept within a Redux container. After that, we create our mock server. And we have to create this mock server in memory. We cannot run it at a real URL. It has to be in memory because it has to run in the same process as the test. So it's created also for the fixture. And this is a one-on-one relation between the mock server and our test data state. After that is set up, we do an initial load. So all the information that is in the database will be loaded into our state management container. So all the information will be there. And we do it like this because querying the database is asynchronous. And talking to a state container is synchronous. So it's easy and fast for our mock server to talk to a state and get the information that it needs, instead of every time waiting for the database to deliver its data or adding it. So after that, we start a test within that fixture. And the first thing you have to do, like I showed you in the image before, is we dispatch some test data. So it's an action. It will be sent to the database. We chose to save all the initial data in our database for debugging purposes. So after you ran your test and you think there's something wrong, you can always review the test data that was created. Because there can be some randomness in the data because of fields you don't need really. You can always look at it back. Well, all that information then is again fetched and saved in the store again. So it can be easily accessed by our mock server. This is a loop. So within your test case, you can do that multiple times. For all the calls you want to mock, you can do this. Then the page will be opened. And when the page is opened, it will query your GraphQL server, because that is how the UI is built. And every time the query will be sent to the GraphQL endpoint, our request mock will be intervening or intercepting this request and execute this against our own mock server. And then a response will be made, and that response will be sent back to your application. So the information you see is what you have set up before and added in or filled in with all the automatically filled fields from our GraphQL server. And it's also a loop. Okay. After that, when you're running your script, there are multiple test actions. You're filling fields, clicking buttons, you're working your flow. And some actions will have consequences, like it will send another query to your server, or it will create a mutation. And the mutation is like a write action for a GraphQL server. So when that happens, okay, let's send that information to our mock server and update our state. So the next time that we're looking at the information or reloading the page, we've got our updated information ready to view. And you don't have to be reliant on the application itself. You can also dispatch updates to your state yourself. Like for instance, you know it will be an updated event, but you cannot get it because there's no real server, so you create your own update event, update your state, and then your page will show that information. Okay. And the most important part from our test tool perspective is that we need to intercept these requests. Like I said, the GraphQL server is not running really, it's only in memory. So you have to execute something against this server without sending a real request to an outside location. And within Test Cafe, it's called a request mock. And what we give with it is our test data server. It's our server that's running in memory. It will respond. We intercept every request that is going to GraphQL data. That's our endpoint for GraphQL requests. And we are going to build a response. And by building this response, you have access to a request and to the response object itself, so you can view what is sent to the server normally. And what you normally would do, is that this event is sent to the server and a response will be created by it and sent back. Because we can do that, we have an execute operation function. This will accept a normal GraphQL request and just process it like a normal server would. And then it will be sent back to our request mock. And we create like a wrapper around it, like, okay, this call was going okay. We're sending you back a 200 status response. It's JSON. All our responses are JSON. And we set our body. And the body is the response from our mock server. So we viewed the first part. It's from the testing tool perspective. But now we'd like to see how is the Apollo mock server set up, because it's not there automatically. You have to do some work. And just a small intro into GraphQL. It's based on a server and a client combination. The client is built into the direct application, and it will fire queries or mutations or subscriptions to your server and process the data when it's returned. The server is set up. You create a schema, is how it's called, and you define your types, your objects, your fields, and you also define what queries can be fired against it. Because the server, if you fire an unknown query, will just error and just won't respond with any information. And you have to really build this schema because it will always tell you what fields it will return and what type of fields it will send back. So if you're like an example, so you've got a book, so it's an object. And for GraphQL, it's a type. So you've got a type book, and it does multiple fields. For instance, a title. We also define resolvers, and resolvers is like an internal methods, like functions, to process data that is coming back from the backend services. And well, the backend services are there. they have a database connection, they have REST endpoints, and a GraphQL server will talk to those. That's really the basics of this. You can find more information on apollographql.com if you'd like to know more about this and the setup of it. So back to mocking this. Apollo GraphQL really gives us an easy option to start with mocking. You can just start your server and saying, mocks is true, and it says, okay, I know you don't have a real schema, I will just send back whatever you want. But you can also use an introspection query. An introspection query is really a copy of the schema of a real live GraphQL server. So you have your server running in production or in acceptance, and you just create a copy or an introspection of that schema and load it into your own mock server. So you have access to all the queries and all the mutations and all the fields that would normally be there. So you don't have to do anything yourself. It's all automatically done for you. And then you can mock the types of fields, like the responses to these fields. So what will I be sending back? So how does it look in setup? That's just this. So we have an Apollo server. We define a query, a very simple one. It will just send a query hello, and I get a string back. It's very simple. And we create our server, and we're saying mocks is true. That's it. Just start it. And then when I query this server, and I send the query hello, I will get a response. And the response from this mock server will be hello world. Because a few defaults are set in this mock server, like strings will always be hello world, and an integer will always be a random number. That's all taken care of by Apollo itself. It will just look at the field, look at what type it should return, and just try to create a response for you. For all the other objects that are created by yourself or by your developers, you have to add it to your mock server. You have to say how it should respond to that object. We'll show it a little bit later. So because this is the one where we add a introspection result. So we've got our schema, we build it, and we add it to our Apollo server. We're still saying mocks is true, but now you have access to all the queries, all the objects that are already present in your normal server. And now we're getting somewhere where we are going to try to change how our server is going to respond to our queries. Like I said, we have got an int or a string, an integer string. And what we're saying now is every time an object is requested and there is a field of the type integer, just respond 6. And instead of hello world, we want to respond hello for every string. You can also mock resolvers. That's on the top. So it's like a resolver is like a callback function. It's like a method in which you can perform actions on your data or manipulate your data and just create a response based on what you're getting in and what you want to get out. So in this instance, we've got our resolved query, and we want to let it respond resolved. But now there's a small extra step you have to take, because every time you query your Apollo server and it sees you want to respond with a string, it will send back hello. And we don't get our resolved response. So there's a Boolean, like the mock entire schema. And what it says is you only have to respond with your defaults if the resolver or the object is not yet defined. So for every undefined field, it will respond with the defaults. So how do we use that in our real life situation or in our test setup? We've got the resolvers. For instance, for a mutation, we get some arguments in, like some variables, like you're mutating something, so it's the new ship name or the visit date. We update the movement. It's sent to the store, like I said before. And after that, we will return a mutation result. So it's like okay, I've done a good job. And we've got our queries. These are all based, you have your schema, you can see what queries are created, and we create our resolvers for those queries itself. And all our queries will go to our state management tool. where our test data is kept. So every time we query a ship, it will ask our state management, hey, I want this ship, this is its identifier, please give me all the information you have. And it will send back a nice JSON response. And the GraphQL server will process it and send it to our UI. Same counts for visits and movements. And for some fields, we don't have to create elaborate resolvers. Like we've got a date-time field. Well, every time you find a date, just return a new date. I'm not really interested in some. But if I want to, I have to set up my data, add the correct date field that I want, and then it will just skip that default mock. So these are the defaults, and the resolvers are coming first. So that is our mock server. So we now have our tool. The tool is talking against our mock server. We are intercepting all those requests. Our mock server is running. It knows how to respond to all those queries. And it knows where to get the data. But where is it? It's in our Redux store. Also a small intro. If you don't know Redux or SQLite database, it's a state container. So it will keep a unified single source of truth object tree with all the information that you need. And for us, it's visits and ships and movements and so forth. We use Redux Toolkit. It's like an easy method to talk to your state management tool. And through actions, we can update the database and update our state. And then we have selectors that will return the information to the ones requested. And why did we need this? Because our original setup didn't use a state management tool. We just said, well, okay, yeah, just return this information. But what we forgot, or didn't think about in the beginning, is that test data is related to each other. So a movement is coupled to a visit, and it has a ship, and it is all linked together. So let's use this database, because that's relational, and just let that manage all the relations between these entities. Tests are run in parallel and will require a certain data set. And if you don't manage it by using, for instance, a test ID or a fixture ID, you can have a situation where you have the wrong test data on the wrong moment in your test, and your test fails, and you're looking at it and you don't know why. So we needed something to make clear which test set is for which test case. And the mock GraphQL server, it's running in memory. It needs to access these responses, this data to create responses. Sorry. Well, this initial data, I think I can skip this one because I would really like to get to the next one. And this is what I showed in the flow before. Every fixture has its own state, so the state is coupled to that group of tests. And therefore, you isolate your test set to your group of tests, and you don't have that interaction anymore. And at any time, the state can be managed by performing actions on it, and the server always has access to the latest state that's there. Simple Redux flow. You've got actions. Actions update your state. Your view is dependent on this state, and your actions are performed from there. They also had a nice animation. I think where you can see UI, it will be our test tool. But we do have to store the reducers, the state, where all the management is taking place. So we don't have to do it all the same. We make use of the Redux state management. You don't have to do it yourself. Just make use of the tools that are there. I've got some example slides, but I think I'm going to skip this one. They will be in the PDF, or later you can view them. It's just how to set up a Redux state and how to perform information from this. I'd just like to get to the end of this. We've seen it all. This is our complete setup. We've got our test tool. The test tool is working on our application. The application will send requests to our mock server. Our mock server will retrieve information from our state management tool. And that will be sent back to the UI. And you can test your application, your pages under test with only that information or that data that you need there. So very isolated. No need to be dependent on other services. Some lessons learned. GraphQL client expects a 100% matching response to the request. So every field requested in a query must be in the response. Some fields can be null, but not all. So you have to keep that in mind. And luckily, our Apollo server will always respond with all the objects and all the fields that are there. A standalone mock server won't work. Like I said, it has to be in memory. It has to be in the same process as your test. We needed identifiers to separate our test data because we would like to run parallel tests or run tests together, and we don't want test data interacting with another. And storing and fetching information in the database async. It's something we forgot in the beginning because we opened our page and we didn't have any data. And we couldn't understand why in the beginning until we saw that just updating the database and fetching the information was taking some time. I want to thank you all for listening. My name is Stefan Schenk. These are some pages you can visit. I will share some code, some examples of our setup on my GitHub pages. So you can always review what is there. And if you want to set up something like this, just look at examples and information I will save there. Thank you very much.
Thank you, Stefan. And now it's questions time.
In the back.
Thank you for the talk. I was wondering who's taking care that the mock server is in sync with your real server. Imagine the schema changes. Do the developers also change the mock server? Do the testers? Does nobody and the tests break?
Yeah, well, we do it all together. The nice feature of using like an introspection query I talked about before is that every time the real server is changed or the models are changed, we can recreate that introspection result, and our mock server will automatically use the same changes and the same models that they've done. So we ask our developers that if you change something in our GraphQL server, please always update the schema and update our mock server. Yes, thank you.
Ja, eerst dankjewel. I have two questions. The first one is, as you said about mocks, I think you control the data that you're mocking from tests, right? Mm-hmm. Do you use this data in assertions? Because I didn't see any.
Yeah, because what we're trying to do is test the application and see how the flow is working, and we need this data to let the flow work as it should be. So our assertions are not really on the data itself, but how the application is handling or showing that data there, and how it would react on actions performed on the page.
Mm-hmm. Good. So you generate this data, you don't use kind of static files stored somewhere, but you... No. Okay, good.
Because we would like the possibility to be a little, I say it, to change the data as needed for every test case there. Yeah.
Cool. And the second one is regarding infra. How do you run all this stuff? Locally, if you develop and you need to run this state server, SQLite, you need to run GraphQL, you need to run your web server, and you need to run tests, and the same in CI if you have so?
Yeah. Yeah, you can just run it locally because, the SQLite database is on the file system, so you create it locally on your file system. The mock server is in memory, so you don't have to really start something up or run it on a certain port. And we build and run the application locally if needed. But we can do the same, it's the exact same steps on our CI pipeline. Yes. Okay.
Thank you. Now the questions time is over, but I think you can actually ask one-to-one questions from Stefan and also from other people in his team. I see at least 9 from the testers. So please, one more applause to Stefan.
Thank you very much.